There we are. Did you find the assignments for this week?
Yeah, I already saw them posted on D2L, correct?
Yeah, posted on D2L. Had a video of them and posted the sheet of assignments. Did you have any questions?
No, I was going through that fairly somewhat easy. It was kind of self-explanatory, the study guide, correct? For the test?
Right.
Yeah, I already looked that over.
Okay. Sounds good. Did you want to see any problems work this morning?
No, not really. Not at this point.
All right. Well, we are covering section 4.5 for this week. Should I charge into preview of what the problems are?
Oh yeah, sure.
Okay. Let me just give you a brief spiel. The 4.5 is about solving equations, two kinds. Number one is exponential equations. So in other words, we might have you solve e to the x equals 4. And so what you want to do is you want to undo e. And that's done with the ln. It's paired on the calculator. Functions that undo each other are paired on the same key. It's how your calculator is constructed. So we take ln both sides. An ln of e to the x, and on the other side an ln of 4. These undo each other, leaving the x, and ln of 4, you can leave it, sometimes the book will leave it ln of 4, and sometimes they punch the decimal. And it's a pretty easy punch. ln of 4, 1.3863. To 4 places. Okay. Another kind comes in when you change the base. Change base. There's a couple methods you could do that. Note you might want to solve 2 to the x equals 4. Well, some of them, like this one, are so easy, you can do in your head. Hopefully it's obvious that x is just 2. 2 squared equals 4. Okay. But sometimes, but a lot of them, it's not this easy. So we could solve, let's change the 4 to a 5. And somehow, there's no clean number, whole number that would give you 2 to a power, give you 5. Next one would be like 8. 2 to the x equals 8. Your x would be 3. You can do in your head. But you got other numbers between 4 and 8 or whatever, 2 to the x equals 7, 2 to the x equals 9. Method 1, use log base 2. So a log base 2 of 2 to the x would equal a log base 2 of 5. These then undo each other, leaving the x, and you you have a log base 2 of 5. The only way you can work that out is change of base. It'd be an ln of 5 divided by an ln of 2. Ln of 5 divided by an ln of 2. 2.32, I guess we use 19. 2.3219. My voice is a little rough today for some reason. All right, well, I don't know if I can keep that up to contrast it. Ran out of paper. Method 2. Two to the x equals 5. There's an infinite number of bases in the world. There's a lot of people who throw up their hands. They don't want to use log base 2 or log base 1. Just use ln. Always use ln. So I have an ln of 2 to the x is equal to an ln of 5. Now the ln is base e, 2 is not base e. These do not directly cancel. But by law 3, bring the x to the front. X ln of 2 equals ln of 5. The x can come to the front. Now divide both sides by ln of 2. And you have your change of base that you got identical to the change of base. Ln of 5 divided by ln of 2 punches out to 2.3219. So instead of worrying about whatever base is in your problem, just always use ln. And it will work out to the same change of base formula. Maybe we should pause for station identification. Any questions about that? We've got another participant, but I can't see the names on this screen. We're working problems from 4.5 to introduce 4.5 for this week. Maybe we should try a book problem. This is off 405. Problem I'm sorry, it's off page 404, my fault. 4.5, page 404. I guess we'll start with problem 3. Solve 5 to the x minus 1, 125. Okay, now they're telling you to do by example 1, and the reason for that is I can go 5 to a third power equals 125. This has been cooked to work. But you may not recognize that. I may not recognize that. I like to use one method every time, and I don't want to mess with a base 5. So I'm going to always use ln. So take ln. ln of 5 to the x minus 1 is equal to an ln of 125. X minus 1 then can come to the front. It's got 2 pieces, so I'll make sure it's in parentheses. Divide by ln of 5. Kills here. X, I'm sorry, I meant minus 1 there. X minus 1 is equal to ln of 125. 20, God, I'm not writing good today. 25 divided by ln of 5. And finally add 1. And I come up with ln of 125 divided by ln of 5 and add 1. This might be a little longer than you need. Probably is, if you recognize that you could have almost done it in your head. But it works every time, and it'll work for all the rest of them, because you can't do the rest of them in your head. Further down the page, no way you can do them in your head. So I'll punch this out. ln 125, barely read that, can't you? Divided by ln of 5. By itself, that's a 3. Add 1, you get a 4. X equals 4. You can almost see the check in your head. 5 to the 4 minus 1 equals 125. Sure enough, 5 to the third equals 125. 5 times 5 times 5. So yeah, on this one, this is a little long. If you could recognize you'd do in your head. But I find there's less confusion if you do them the same way every time. So I could go on and do some further down the page that you can't do in your head. Anybody want to stop and ask me any questions about this? Can y'all still hear this?
Yeah, can you do one of the harder problems?
Absolutely. Call one out to me, because I don't know what's harder for you. I can do them all. Not bragging, talking smack, but what's harder for you?
Hold on, I just opened my textbook.
Oh, okay. We're on
I was
page,
still getting set up.
sure, we're on page 404. You want me to just pick one?
Yes, please.
Oh my goodness. Okay. Why don't we try one? Well, I'll try a simpler one just to get you warmed up, even, but you can't do it in your head. Problem 11, and then we'll do a harder one with more steps down the page. But we're still on page 404. This is 4.5. First problem of that next section, 11, solve 10 to the x is equal to 25. Okay, so you're not going to do this in your head. There's no even power. 10 to 1 is 10, 10 squared is 100. So it's a number between, you can tell it's a number between 1 and 2. Number x is a number between 1 and 2. Because 10 to the 1 would give you 10, and 10 squared would be 100. You want the answer to come up 25. So between 10 and 100, so the answer's got to be between 1 and 2. But unless you're an absolute genius, you're not going to come up with it. So we take ln. ln 10 to the x, ln 25. X to the front. We're going to divide by ln 10. There's our change of base, that if I'd used a log base 10 on both sides, I'd got a log base 10 of 25, which works out ln 25 divided by ln 10. So take ln 25. By ln of 10. 1.3979. 1.39, oh, I don't know if I showed that. Okay, 1.3979. Sure enough, it's between 1 and 2. If you wanted to check it, this one's simple enough to check. Most of the ones we'll check with the back of the book because they would be a lot harder to check, but we could go 10 to the 1.3979. See how close we get to 25. 24.9976. So pretty close. We'd taken out more digits here. We'd got more digits closer to 25. Trying to give you some confidence in all this gibberish. Did you come up with a harder problem you wanted to see, or do you want me to pick one?
Um, can you do 37 because it's in a fraction?
Absolutely. Let me start so I don't have to switch paper in the middle of the problem. Let me go ahead and start on the top of the paper. 4.5, page 404, 37. Solve 50 plus e to the negative x comes up 4. Yeah, you want to clear your fraction on this one. So your common denominator is your bottom one plus e to the negative x. So I'm going to multiply both sides by that. One plus e to the negative x times 50, 1 plus e to the negative x is equal to 1 plus e to the negative x times my 4. I haven't done anything yet. I've just simply multiplied both sides by this denominator to clear it. That leaves my 50. I'm going to distribute through from the back side 4 plus 4e to the negative x. We losing anybody so far? Anybody want to ask any questions about this?
Not yet.
Okay. The rest of this is just steps on both sides to get to this e by itself. You want to get this by itself? When it's by itself, take ln.
So now it's just basic algebra.
Basic algebra. Subtract 4 from both sides. 46 equals 4e to the negative x. If it bothers you that things are reversed, you can of course switch it. 4e to the negative x equals 46. I don't know if that bothers you or not. All right. So the next move, get rid of the 4, so we got to divide by it. That won't come up even. You could leave it 46 over 4 or get a decimal now if you want. I think I'm going to leave it 46 over 4. Now I'm ready for the ln. ln of 46 over 4. I'm putting in parentheses because it's got to be or it won't punch right. These do directly undo. That leaves the negative x, ln of 46 over 4. And the final move is to divide by negative 1. And that'll just turn it to a negative ln of 46 divided by 4. And that's sort of the exact form. Sometimes they leave it in exact form. Sometimes they give you the decimal in the back of the book for an answer. I'll go ahead and punch it. Negative is the short negative at the bottom of the screen. I'm sure y'all familiar. Negative numbers are punched with that negative. It's not the same as subtract. When I want subtract, I use the subtract key. All right, so that's a negative and ln 46 divided by 4. Negative 2.4423. 23. Show it again. Questions about that?
No.
Okay. Maybe we'll try one more and then we'll get into the log equations.
Okay.
How about one with yeah, 31's got a trick in it. It's got two different bases. Page 404, page 404, 31. 4 to the x, all right, we're going to solve 4 to the x, add 2, 1 plus 2x, and it comes up 50. Would y'all know instantly what to do on this? Or does this make you scream, why did I sign up for this class?
I have no idea.
Okay. Let's see. You want to get you'll want to get to the same base. I wonder what they're doing with this one. Use either base 2 or base 4 because you could go either way. I'd say convert this to base 2. In other words, 4 is 2 squared. So you'd put a 2 squared there and you're raising that to the x. Oh, I see what they're doing with it. Oh, you got to play. Oh, yeah. I'll tell you what. This is one of those quadratic forms. Yeah, okay. This is one I tried to avoid from last section. We didn't get into one this complicated from last section. I'll tell you what, just cross this one off. It's from last section, the quadratic form. It's a quadratic form. I get what they're doing. Don't even worry about it. Let's try 33. Solve 5 to the x equals 4 to the x plus 1. Okay, this is why I'm trying to tell you to take ln. Because you got two different bases on this one. If I use a log base 5, I can cancel this side but not that side. If I use a log base 4, this side cancels but not that side. Occasionally I'll get people who do a log base 5 of 5 to the x is equal to a log base 4 to the x, 4 to the x plus 1, and cancel this and cancel this. You see the problem with doing this? You've done different things to the sides. You got to do the same thing to both sides. So that's why I'd forget the log base 5, forget the log base 4, just use ln. ln of 4 to the x plus 1. But since nothing cancels now directly, we put the powers in the front. X ln of 5 equals x plus 1 ln of 4. There's several ways you can go from here. You can go ahead and pop in the decimals, and it just works out with decimals. I like to keep it to at least 1 decimal. I like to go ahead and divide by the ln of 5. And that way I only have to work out 1 decimal. I get a plain x here, x plus 1. And now the only way to really go is go ahead and get your decimal for this. ln 5 divide by ln 4. 1.16, I'm going to call it 1.
Wait, I thought you had to divide ln4 by ln5.
Oh my goodness, I am asleep this morning. You're absolutely right. I got it backwards, upside down. Thank you so much. It's ln of 4 divided by ln of 5. You're absolutely right. So it's 0.8614, we'll call it. Thank you for saving me from my folly. The rest of this is pretty straightforward. It's just you got a nasty decimal instead of whole numbers. So we got to distribute through there, 8614x plus 0.8614. We're going to subtract 0.8614x, 0.8614x, 14x. If you're wondering what the heck to do with that, well, you just got to remember you got a 1. And you don't punch the x's if you don't want to do this by hand. You just punch in 1 minus 0.8614. 1386. 6x equals 0.8614. This cancels. Last move is to divide by 0.1386. And you wind up with a decimal answer. 0.8614. I'm off here. Okay, 0.8614 divided by 0.1386. 6.215. Now that may or may not be the answer in the back of the book. If I take time to look it up, this is what, section 4.5. It was problem 33. Okay, so the book kept to an exact form. Right there, problem 33A. Oh, they gave you the decimals in B. So they actually asked for both. You don't have to come up with this form of the answer. You should be able to punch this and get this. But there's the 6.21. I'm coming up with 215. They're coming up with 6.2125. That's just my bad rounding. The rounding just compounds. So this is fine. Are we ready for the last? Oh, we're at almost 30 minutes. Are we ready for the last form here? These are log form equations. Did anybody want to ask about that last one?
No.
Okay. So if we jump over to, what section did I ask for? Anybody have the assignment right in front of them? I think I might have asked for section 49.
It says 49 through 53 odd.
Got it. Thank you. Yeah, so this one last little section of log equations. Let me just try a really simple one. You want to undo your log. Now, if I wanted to solve log of x equals 3, I would use base e. E to the ln of x equals e to the 3. These directly cancel. X equals e raised to the 3. I can punch that out. E raised to the 3. 20.0855. If I want to solve log of x equals 3, I use base 10. Log on the calculator is paired with 10 to the x. Show you those keys. See ln and e, they're paired, they undo. Log is paired, if you can barely see it, a 10 to the x. So that says base 10. I go 10 to the log of x is 10 to the 3rd. These undo. Should be able to do 10 to the 3rd in your head. 10 times 10 times 10 is 1,000. That's the basic idea. And of course, the ones in the book have more steps. We'll try 49. Still on page 404. 49. Log x plus log x minus 1 equals log of 4x. Okay, we're in base 10 here. But we have got to work this down and simplify it. So I guess we'll call it law 1. Use law 1. If logs are spread out like this, you can compress and write that, if you remember, as a log of x times x minus 1. Log of 4x. If you can think expand again, if you had this written down, that'd be a log of x, add your log of x minus 1. So we're using the law backwards, compressing it back. Now I use base 10. 10 to the log x, x minus 1. 10 to the log of 4x. Should we pause for station identification? Are we losing anybody on any of this?
Not yet.
Not yet. These undo, this undoes, bringing us down to x, x minus 1 equals 4x. This power equal to that power then. Rest of it is just basic algebra. X squared minus x equals 4x. You don't want to send the x over. That gives x squared equals x. With squares, letters, and numbers, you want the 4x over. Subtract 4x, subtract 4x. That gives you x squared minus 5x equals 0. You could use a quadratic formula with a c of 0, but I hope you recognize that you can factor this. Factor out x. X times x minus 5. Your lead x is 0. By itself, you're setting each piece to 0. Piece 1, x equals 0. Piece 2, your x equals 5. Now, if you proudly box these in and report these as your answers, you are going to be horribly disappointed. You've got the same problem as you did on the fraction equations. Well, you must check for illegal numbers. I'm mentioning fraction equations like I'm teaching college algebra here. I just covered that with college algebra, but you guys aren't college algebra. Equal numbers. Any number that you get has to be checked or be able to be plugged back in up here. And turns out, I'll show you what happens. Maybe I should just punch it and justify it that way. If I try the 0, log 0, error. Okay, let's compare it to a square root. I can do a square root of 0 and get 0, but you know you're not allowed negatives. Square root of -1 is an I. It's not allowed. It's illegal. All right. Log works the same way, except you can't even use 0. Log is identical, except you can't even use 0, which I just showed you. So in other words, plugging these numbers back, log 0 there, I'd get a 0 there as well. It only has to occur in one spot. 0 is illegal. It's out of the domain. 5 will work. So you want to check for 0. You also want to check for negative numbers. If I put a number back, will I get a negative? You can do 5 in your head. Log 5, 5 is positive. 4 minus 5 minus 1 is 4. That's legal. This give you a log 20. So that's legal. Only correct answer is x equal 5. Let's pause for station identification. Did we lose anybody doing that? Anybody need more explanation on illegal numbers?
No.
Okay, if this does not come up with exponentials, you don't have to worry about it with exponentials, which is why I didn't mention it. You can stick anything into an exponential and take e to the power or 2 to the power. There's no problems whatsoever. But with log, you've got problems. You've got to check that the logs, you must check, I'll write it down. You must check answers so your logs stay positive. That means you can't even use 0. Technically, 0 isn't positive. 0 is the boundary between positives and negatives.
So if it had been x minus 6 instead of x minus 1, we wouldn't have been able to use it?
If it had been an x minus 6 and you'd come up with 5, that's right, 5 would have been illegal.
Okay.
Because 5 minus 6 would have given you a negative here, and that's illegal. We're at 40 minutes. You want me to try one more?
I don't care.
Don't care. Patience for one more?
Sure.
You want me to try 51?
Sure.
Log x equals log 2. Add log 3x minus 4. All right. But the combine is going to be on this side. And again, because both are positive, I can multiply the 2 and this. Log x is equal to log of 2 times 3x minus 4. That's why they had you do all those exercises of expanding logs and combining them. I'm combining this to this. All right, I'm not ready to do my base 10 yet because the 2 isn't up as a power. So that's a log x squared, log of 2 times 3x minus 4. Now I use my base 10. 10 to the log of x squared, 10 to the log 2 times 3x minus 4. These will undo. X squared then equals 2 times 3x minus 4. Very common, both of these have worked out quadratic, very common. One of these answers works and gives you positive logs up here and one doesn't. Now that's not an absolute rule. It could be cooked so both work. It could be cooked so neither works. But the most common situation I've seen, we're going to get 2 answers out of this. One will work, one will not. So we'll see how this one works. You see I got to distribute the 2. 6x minus 8. I got to bring these pieces over. Minus 6x, add 8 would equal 0. Are we going too fast? You're going minus 6x. Go ahead.
I was just going to say, no, you're fine.
Okay. Factoring on this would go 2 numbers multiply to 8, add this negative 6. Looks like it'd be x minus 4, x minus 2. That's going to give you x equals 4 and x equals 2. You switch the factoring. So we're going to check for illegals. You do this in your head. It's just a matter of putting the numbers back up and seeing if you get a negative. So we're back 4 there, 4 there, and see if any of them turn negative. I think you can tell in your head they don't. And I think you're fine with a 2 on this one too. 2 log 2 be positive there, and 2 times 3 is 6 minus 4 is also positive there. I think you're fine on both of these, but I can write it out just to show you. You'd have 2 log 4. This is checking x equals 4. Log 2 plus log 3 times 4 minus 4. You don't even have to work this out. I'm just checking for positives there, and this would work out 12 minus 4, 8, log of 8. No problem there. 2 log 2 equals log 2 log of 3 times 2 minus 4. This is fine. And you got 6 minus 4 equals positive 2 here. This is fine. So both answers are legal on this one. X equals 4 and 2. So this one was cooked that both worked. It is very common on these that one works and one doesn't, but not on this one. Any questions about that? We're at 45 minutes. Does anybody want to see anything else?
Can I ask for one more of the exponential ones?
Sure. Which one?
Number 25.
25. Okay, this is back on page 404. Well, we're still on page 404. Section 4.5, solve 3 to the x over 14 equals 0.1. Once again, I'm going to use ln. ln of 3 to the x over 14, ln 0.1. Again, these do not undo. X over 14 times ln of 3 is equal to ln of 0.1. Now I could start punching in these decimals and you can play it that way. I'm going to divide by the ln of 3, group my ln's together. X over 14, ln of 0.1 divided by ln of 3. And you could punch this if you wanted right now. If you want, I'd like to punch it all at the end. To get the x by itself and get rid of 14, I'm going to multiply both sides by 14. That'll clear the 14s. I'm going to put the 14 in front. ln of 0.1 divided by ln of 3. That might be the form the book has. Did that go too fast?
No, it was easier than I thought it would be.
Okay, I'll go ahead and give you the decimal. 14, oops. 14 ln of 0.1 divided by ln of 3. Negative 29.3426. Yeah, it looks horrendous. Looks like a lot of gibberish. But it's just a matter of realizing the phrase is the only log you need is ln. Rather than trying to tailor what you're doing to whatever base they have. We have no quiz this week. We're having the test. It'll be there on Friday. It works exactly like the quiz. It's just that it has problems covering all of chapter 4. Some will be correct, some will not be correct, and you'll put your answers true or false on a Google form. Next Zoom meeting, then 8 o'clock on Thursday. Anybody want to say anything or ask anything then before we end?
That's just about it. Thank you very much for working on the problems and stuff.
Absolutely, no problem at all.
Thank you.
Yep, sure thing. Hopefully see you on Thursday. Appreciate you coming out this early on in the morning. Thank you.
No problem. Have a good one.
Okay.